then share my screen. Okay. All right. Okay. So what we have here is our first set of practice problems. And so at the top here, you're going to notice these are going to be our in-class examples that we're going to be working. And these are going to lead into and mimic the application problems that are going to be for Module 1. So in here, we're going to be working all of the problems that are here front and back, and they're examples of the type of math that we're going to hit in this course. But at the top here, you'll notice you can earn one of two grades. You can either earn 10 points or you can earn 0 points, okay? Now remember, practice problems are 20% of your grade. So it's important that you follow along, that you work these problems, and that you hand them in. Now, I am looking for completion. I'm not going to go through each one and check the answer because you're going to be getting the answers as we go along. Remember, it's also a one chance to submit, minus this very first one. So if there are issues on this very first one, I will do this one reminder, but starting in Module 2, one chance. That's it. Okay. Because I am showing you exactly how to do these. Now it says here, follow along. I'm going to move my thing over here. It says follow along with the lecture demo in Module 1, work the following practice problems on a separate sheet of paper. Okay. Do not put them alongside down here. I'm not going to accept it. There's just not enough room. Okay. So separate sheet of paper. Be sure to show the original problem. I'll show you exactly what I mean by that. And all the steps taken to find the answer. Okay. Show your work means very different from one instructor to the next. So that's exactly what the practice problems are for, so that you know exactly what I'm looking for and how to format things. Put a box around your final answer. If you don't do that, it's called a 0. All right. So I want you to answer the question. Always like definitively tell me this is the end. Okay. And then I want you to use pencil, only pencil. Do not use pen. If you make a mistake, and you will, it needs to be erased, and then you need to move on and so that it can be neatly read by me. If I can't read it, it's wrong. So if your penmanship isn't good, you're going to have to slow down and just take your time. Okay. Yes. That's okay. That's okay. Yes, that's okay. That's all right. Erasable pen is okay, because what is distracting is if you like cross it all out and then you start again. You're handing stuff in. You're at a collegiate level. You want to put your best foot forward. It's an impression that you make. Now, not that you have to impress me, but just remember that when you're out in industry, you're gonna have to share your work with other people. Show them what you did. And if they can't follow along or you can't read it, I mean, it kind of gives an impression. Okay. So we're practicing that here. Now, an important note, this assignment is graded as completed with 10 points or not completed. We will be working each of the problems during our scheduled lecture demos. To earn all 10 points, you will need to complete each problem and show the formatting demonstrated in class by the instructor. You can't be like, well, I normally do it like this. Okay, but then you won't get the points, okay, if it doesn't match. If there are any problems, if any problems are missing or formatting not followed, you won't earn the points. And remember, it's 0 or 10. I'm not going to give anything in between. I'm telling you right up front, you got to do them like this, and I'm giving you the answers. All right. So it's a matter of just following along and copying, basically. Okay. But you're working along with me. So make sure you always bring paper to class, a pencil, and your calculator, because you're going to want to work these along the way. And it makes lecture more interesting. If I would just be sitting up here lecturing and just showing you problems, I don't know, I think that's kind of boring. So we're going to be doing them together. And that's the whole purpose of handing in the practice problems. I want it to be more interactive and hands-on for you. Okay. So what we're going to do is you're going to notice that we have problem set here, number 1. Now, the first thing it says for number 1, it says solve for V. You do not need to write out solve for V, but what you will do is you will rewrite the original version of the problem. So you're going to be writing out D is equal to V times T2 minus T1. Okay. So now when you hand in your homework, it's already going to be Module 1 practice problems. And I know they're coming from you, so you don't have to put that at the top, but we do have different sets here. So I would start this with set number 1, right? I think it's called, yeah, set 1. You don't have to put algebra, but then you're just going to number your first problem. Okay. Please do them in order. It just makes it easier for me to try to figure out. And if you do skip around, just kind of put the number where it's supposed to be and then come back to it. But don't like go 1, 2, 3, 4, 5, then do 8, and then do 7, then 6 or something like that, okay? Just makes it easier for me. So we're gonna write our problem out. So I'm actually gonna give myself a little bit of room. D is equal to V times T2 minus T1. Okay, so we want to write the original problem. Now, in this case, we are going to be solving for V. So we want to get V by itself on one side or the other. So since this is already on the right-hand side of the equation, I'm going to leave it on the right-hand side because it's in the numerator. And then I'm simply going to get rid of the other stuff. So you'll notice that V is multiplied by, in parentheses, T2 minus T1. So I need to get rid of that. How would I get rid of T2 minus T1 on the right-hand side of the equation? Exactly. So I'm going to show how I'm going to divide that. So showing your work is then going. Now you can use this very first line to do this work. So you can go a division line underneath. And you're simply going to be divided by T2 minus T1 in parentheses, which means that this is going to cancel out on both sides. Show the cancellation. And then you're going to do that very same work on the left side, T2 minus T1, right? Then you'll notice that V is by itself on the right-hand side. Your final answer, though, will be writing this out. D divided by T2 minus T1 equal to V, and this is what you put your box around. Make sense? This was showing me how you did it, and this is showing me your final answer. Now, something that you'll notice is that, and in this one, I think it's more obvious, but as we go through, I want you, well, I'm not wanting to, you need to do any fractional work in what I'm going to call up, down, or numerator, denominator, up at the top and a bottom, not the slash. Now you're going to notice I use slash, might be in the next, well, not in this problem, but in this problem down here to show a division only because I was working in Word and I didn't have the ability to make it like the up, down version. But I do have this note here, these two asterisks where it says, make sure to write all original equations in up, down, not slash format. Even though I'm showing the slash here, rewrite it so that you have a numerator denominator, okay? This becomes really important because when we go and we analyze equations, and you probably had this in physics, you have to like get rid of units or add units or combine, and doing it in the up, down is the best. Yes.
Do you mind, or do you have a preference if we go across or if we just work down the page?
Oh, I don't care. As long as you number them and it kind of makes sense. So if you're going to notice I'm going to go down because I don't have a whole lot of room over here. But if you go across, that's totally fine. Yeah, just number them for me. Yep. So any questions here so far? Piece of cake, right? Piece of cake. All right. So, so let's go to number 2, do that very same thing. So we're going to write our problem out first. So number 2, F times P minus A is equal to 2M. And in this case, we're going to solve for capital M. All right. So here you'll notice that we have the M on the right-hand side. It's already in the numerator, so we need to get rid of the 2 and the lowercase m. So since those are multiplied by M here, I'm going to do what I did on the last one. I'm going to do my horizontal line underneath. I'm going to divide by 2 and divide by M. So that's going to cancel out top, bottom here. But then I'm going to do that very same thing over here, 2M underneath. So whatever I do on one side to clear it, I have to do that very same thing on the other, right? And since it's a multiplier, you're going to hear me sometimes say, I'm going to do the opposite. So to me, the opposite of multiplication is division, or the opposite of adding is subtracting. So, so now I'm going to write my value here. I got M by itself. So I'm going to have F times P minus A divided by 2M is equal to uppercase M, and then box around your final answer. Questions? Now, this is the day that you're going to be bored. You're going to say, this is really easy. And I'm going to be like, perfect. That's where I want you to be. Christian.
Can you write what the problem is in pen? So if we have to erase over, we don't erase the question.
Please do it in pencil, everything in pencil. Thank you. I guess that doesn't matter to me, Christian, quite honestly, but please, I know some people are like, I don't like using pencil. Well, it's, I'm sorry. I need it to be nice and neat. I don't want scribbling, as long as you avoid scribbling. Okay, thank you. I don't want to be too ticky-tack, and I know on these first days, it seems like I'm going to be. So ask any questions you want, and I'll, yeah, I'll be okay. Format wise though, this is important. Okay, let's go number 3. So go ahead and write your equation out. And this time we're going to be solving for capital R. So this is an up-down one. So we have to convert it from what it is. This is an I is equal to, and it's going to be capital E minus small or plus small e divided by, and then we've got a capital R, or uppercase R. So you want to show it like this. Okay, the up-down. And then now we want to solve for R. Since R is in the denominator on the right-hand side, we're going to multiply both sides by that R. So I'm going to put parentheses around the whole thing, put my R out front here, and then I'm going to do my multiplication of my R on the other side. And don't forget to cancel out on the right-hand side the 2 R's. So now I've got Ri is equal to E plus E on the other side. And I need to now get rid of my this I here. So I'm going to divide both sides by I. They cancel out on the left. And I'm going to end up with R is equal to E plus E over I. And if you keep the parentheses around the E's, that's fine. Or if you leave them off, that's fine too. Okay. If you end up doing the dividing of the I in the first line here. So if you would do this, divide by I over here and divide by I over here, that's okay too. All right. I did it in 2 steps, but as long as I can see what you do and it's legible, that's totally fine. Any questions so far? Okay, let's keep going. Number 4. Okay. So again, there's a slash there. So we want to convert it to the up down. So this is going to be number 4. P is equal to, it's going to be B times H times 1 minus A divided by 2D. So this is what you want it to look like. Make sense? All right, so for number 4, we're solving for H. We want to get H by itself. So the first thing I'm going to do is I'm going to get rid of the 2D underneath here because I want to get H by itself. So I'm going to multiply both sides by 2D. So that's going to cancel out here. It's going to be 2D over there. So then I'm going to just take this step by step. 2D times P is equal to BH times 1 minus A. So now to get rid of the 1 minus A and the B, I'm going to put a division. I'm going to do B down the bottom, 1 minus A. So that'll get rid of these on this side. And then I'm going to divide by B times 1 minus A underneath. So now H is the only one left over. So as my final answer, 2DP divided by B times 1 minus A is equal to H. So you want to just put it in its final form. Okay, any questions at all? All right. Number 5. Here we're going to be solving for L. And here again, we're going to have to write it in its up-down format. So number 5, I'm going to have AL divided by, divided by H is equal to K times B1 plus B2. So this is what it's going to look like in its up-down format. And we're solving for L. So I'm going to start by multiplying by H. Okay, so then H is going to be multiplied over here. So I'm just going to add it to the end. So I'm going to cancel out my H there. And then L is going to be a division, right? So I'm actually going to get rid of my parentheses here. And I'm going to divide by L, so it'll cancel here. And then this is going to be a divide by L. So to put it in a nicer, better looking format, A is going to be equal to H times K, B1 plus B2 divided by L. Make sense? Oh, was I solving for L? Did I do that wrong? I did, see? Yeah, all I gotta do is change my A to my, so this needs to be, L is gonna stay, thank you. A is gonna cancel. A is gonna divide over here. And then L goes here and A goes there. Is that better? Shoot. Yeah. So we're dividing by H and A on that side. And then a box around your final answer. All right, number 6. Coming back over here, we're going to solve for R2. R2 is in the denominator on the right-hand side of the equal sign. So remember, write it first in up-down format. So this is going to be E1 squared divided by E2 squared is equal to R1 over R2. There we go. So again, eliminating those slashes. I know I've got them in the problems there, but to evaluate these, it's better and easier to do it on the up down. So we're going to be solving for R2, which is down in the bottom here. So we need to first get that up in the numerator, right? So to get it up in the numerator, I'm going to multiply both sides by R2, right? So R2 comes over here. All right. So R2 cancels out. And then now I need to get R2 by itself on the left-hand side. So that means my E2 squared, it's in the denominator down here. It needs to be multiplied by both sides, right? So I am going to move my 6 up here. I'm going to multiply by E2 squared. So there's a lot of parentheses here. So it'll cancel out on this side, but then it'll multiply E2 squared on the top. So I've got R1 times E2 squared. And then my E1 squared, it's multiplied on top here by E2. So I'm going to divide, make a little bit of room here. I'm going to divide E1 squared. So it cancels out over here. And then I'm going to divide E1 squared over here. So now I've got to look at what I don't have crossed out. So on the left-hand side, I'll have R2 by itself is equal to R1 times E2 squared divided by E1 squared. And then that would be my final answer. Oopsie. Does that make sense to everybody? Did you follow that? And if you want to put that in more than one line, that's okay. All right. All right. And you guys are in calculus, so maybe it's been a little while for algebra. Not, it doesn't look like anybody's confused, but sometimes it's like, oh, I haven't thought about that in a while. Okay, so let's look at number 7. Everybody ready to go on to number 7? Okay. So number 7 says we're going to be solving for H. So here we've got H squared is equal to D plus T. So I'm going to turn my page here. And number 7 is H squared is equal to D plus T. So this one, we need to get the H by itself. It's H squared right now. So it's H times H, right? How do I clear a square? What am I going to do on the opposite side? Square root. And it has to be the square root of the entire side. So I'm just going to cancel this out and I'm literally going to take the square root and go just like that. Okay, that's it. So my final answer is going to be H is equal to the square root of, and make sure that the square root symbol extends all the way over D and T. It's not correct to do it like this, D plus T. That would not be okay, all right? You have to put it over the whole thing. And I always add that little, what is that, a little hook at the end, just to kind of show where it stops. Okay, you don't have to do that. but, and then put your box around your final answer. All right, number 8. Here we're going to solve for t. And we've got 2k is equal to d divided by 2 or divided by t squared. So we're going to draw it first or write it first in its up-down format, d divided by t squared. So we need to solve for t. So first things first, we want to get t in the numerator of the problem. It's in the denominator now. So what would I do to get this in the numerator? Correct. Multiply by t squared on both sides, right? So it'll cancel out on the right. And I've got d by itself, but that's not what I want. So I'm going to rewrite this line just so that I can see what I've got. Okay. Now I've got to get t by itself. So it's multiplied right now by 2k. So I'm going to do that dividing both sides by 2k. So on the left, it's going to cancel. And then, since I'm here already, I'm not going to write this again. If you wanted to, you could, but I've got t squared is equal to d over 2k. So to clear that square, I need to start my radical at the bottom, the denominator of the other side. So my final answer is going to be t is equal to the square root of d over 2k. And make sure you extend it for the top and the bottom, the numerator and the denominator. Okay, and then a box around that final answer. Okay. Number 9. In this problem, we're going to be solving for r, a lowercase r. So 2c divided by r is equal to ar times w. So I'm going to write that first in my up-down format. So 2c divided by r is equal to ar divided by w. So you'll notice we have 2 r's. We need to get them together, right? So what are we going to do here to get them together? Multiply both sides by r, right? So that it'll get rid of it out of the denominator here. So we're going to multiply by r on this side, and then we're going to multiply it by r over here, which means that we're going to have 2c is equal to ar squared divided by w, right? And now we need to get rid of the a and the w. So we're gonna divide 1 over a, right? And we're gonna multiply by w so that our a cancels and our w cancels. So that means over here, we're gonna divide by a and we're gonna multiply by w. Make sense? So now our final answer is going to be, now when we have something like this, W2C, just because of the order that I wrote it in, the 2 should come first in our final answer, best practice, right? If you leave it as W2C, I'll never mark it wrong because it really doesn't matter what order we multiply them in. But the standard way that you'll most often see it is going to be 2 times WC divided by A is going to be equal to our R squared. And then we need to clear our R squared. So we're simply going to cross out and put our radical over the entire thing. So our final answer, I guess I should do one more line. 2WC over A is equal to R. So any questions so far about formatting? You're probably getting the idea of what I'm looking for, huh?
I guess like square root of t plus square root of t, read it twice, where it's technically with that man.
I'm not sure.
Would you be okay with us like multiplying both sides by W over A and little stuff like that?
Yeah.
Yes, I would. Yeah, it'd be fine. And then do like the cancellations. Just make sure you do the cancellations, like so that you can see what's left over if you would. Right. The order of it is not as important to me as that you show me. Does that make sense? Yeah. Cool. Because right now, I didn't teach you guys math. I don't know how good you are. I don't know how bad you are. And I also want to make sure that you understand what my show your work means. Because like, again, it means something different to everybody, right? So, okay. All right, 10. Number 10. So number 10, we're going to be solving for W. And here's our problem. So number 10 is going to be P is equal to 2L plus 2W. So we're solving for W here. So the first thing I'm going to do is I'm going to get rid of the 2L, right? So there's an imaginary positive out front here. So to clear that on the right-hand side, we would have to subtract 2L, right? And then that means that we're going to subtract 2L on the other side. And then there's a positive out front of the P. So it cancels on this side. And then we've got 2 times W and we want to solve for W. So that means we're going to divide both sides by, oops, not 2W, by 2 and divide this by 2. So it cancels on the right-hand side. So you'll notice here that the way that I wrote it, I have a negative 2L out front. Usually you don't want to lead with a negative unless there's 2 negatives, but in this case we have a positive. So we would start by doing P minus 2L divided by 2 is equal to the W. And that would be the problem. Now, let's say you left it as negative 2L plus P over 2. I will never mark that wrong. All right, you did the problem correctly. I'm just showing you kind of like the best practice, if you would, but it's not wrong if you would lead with the negative 2L plus P. All right. 11. 11, we're going to solve for P1. So we've got P2 minus P1 is equal to EI. So that's a capital I, not a 1. So we want to solve for P1 here. So notice that it's a, we've got a P2 minus P1. So to get P1 by itself, what would we do? How would we get rid of P2? There's an imaginary positive out front here, right? You would subtract P2 from both sides. So I do a minus P2 over here and a minus P2 over here. So it would cancel out on the left. And I'm ending up with a negative P1 is equal to EI minus P2. Now I've got P1 by itself. Am I done here? No. I got to clear that negative, right? On that P1. So what you would do is you would multiply by a -1 on both sides. Or what I like to do is I'm like, okay, I got to get rid of that negative. I'm going to make this one positive. So every other sign on the opposite side of the equal sign becomes opposite of whatever it was, right? So if I made this positive, then the EI becomes negative and the P2 becomes positive, right? Best way to write this. If you leave it just like this, I'm good. All right. But I'm just going to show you, just me being me, I would be a P1 is equal to, I would start with the P2 on the right-hand side minus EI. Just because, again, leading with the negative is something that, I don't know, you'll see most often you don't do. But if you leave it there, I'm okay with that. I won't mark that wrong. And then number 12. Okay, number 12, we're going to be solving for R2. So here, we've got H2 minus R2 is equal to V2. So H2 minus R2 is equal to V2. So solving for R2, actually very similar to the last one. So we want to get rid of our H. That's a positive out front. So we would do an negative H2 and a negative H2 on the other side. So that would clear it on the left. We're left with a negative R2. So that means it becomes positive and the V2 would become negative and the H2 would become positive. So we'd have R2 is equal to H2 minus V2. And again, if you lead with the negative V2, that's okay too. All right. Any questions at all? Okay. Let's turn our page over. On the opposite side here, you're gonna notice set number 2 is looking at solving two equations with the same two unknowns using the substitution method. Okay, so you have to use a substitution method. So I'm going to go through that here, and we're going to, use these 4 sets of equations. So you'll notice at on number 13, we've got 3e minus 8r is equal to 12, and we've got e minus 4r. So by itself, if we would just have the one equation, we couldn't solve for either one of these variables because there's too many variables in one algebraic equation, right? But when we have the second equation with the same two unknowns, now we got a shot, okay? So that's what we're going to practice, is solving this system of two equations, two linear equations, when they have the same two unknowns. Okay. So number 13. All right. So what I'm going to do is I'm going to rewrite these two equations, and I'm going to call one number 1 and one number 2. Yes.
Do you want us to start a new page for these different sets?
Not necessarily, just maybe, you know what? They just kind of keep going. But if you wanted to do set number 2, you could do that. But you'll notice that the numbers keep going, so it starts with number 1 and then there's not another number 1. So you could separate it if you wanted to. If you don't, I'm okay with that too. I know, I sound so, okay. Yeah, it's just a matter of getting used to me. All right, so we're going to write these two equations. I'm going to call the top one number 1 and the second one, the bottom one, number 2. So number 1 is going to be 3e minus 8r is equal to 12. And then my number 2 is going to be e is equal to 4r. Okay. So when we solve two equations with the same two unknowns, the first thing we need to do is, if we don't have it in place already, is we need to solve one of the variables in terms of the other, meaning we need one variable by itself. In this case, you'll notice we have an e by itself on the left-hand side, and the second equation is equal to the other variable in some form. Okay, so it says, okay, e is equal to 4r. So we have that going for us already. If we have two equations and they don't have one of the variables solved for the other, like we see in our next problem here, we have to do that for one of the problems. Okay, but in this case, that first step is kind of done for us. All right, so what that means is, for equation number 2 here, since we know that e is equal to 4r, wherever we see e in the first equation, instead of writing e again, we're going to write 4r instead. Okay, so our step number 1 here is going to look at equation number 1, and we're going to do 3 times. We're not going to put e here. We're going to put 4r. So we're substituting where e was for what it's equal to. Minus 8r is equal to 12. Now you'll notice in this equation, the only unknown that I have is r, right? And that's what we want. So now we can solve this with this algebra. So we're going to multiply 3 times 4, that's going to be 12r, minus 8r is equal to 12. Okay. Now we can combine these two, right? Because they have the same variable. So 12 minus 8 is 4r is equal to 12. And then now solving for r, we're going to divide both sides by 4. Our r is going to be equal to 3. Okay. Now, there are two variables here. We've got r, and now we have to go back and we need to solve e. So we're going to substitute the value of 3 where we see r in the other equation. So notice that we solved for r in equation number 1. Now we're going to go back to equation number 2 and substitute our value of 3 where we see r. So our second step here then is going to be using equation number 2. And when we do this, we always alternate back and forth between equations. Okay. So now we're gonna say, all right, E is equal to 4 times 3, because that's the value for R. So E is gonna be equal to 12. Now, we can check our work. What would we do? Plug those values in. Now, this is something you don't have to write out. I'm not going to make you write this out, but it's not a bad idea to check. So if I go up to, well, we can do it in let's do it in equation number 1. So if I take 3 times 12, which is my E, right? E is 12. So that's going to be 36 minus 8 times 3, which is 24. So 36 minus 24, is that 12? Yeah. And that's all you have to do in your head, in your mind. Just make sure that it all works out. You don't have to write it out unless you want to, but I'm not requiring that. Okay. So how many have done substitution method before with this? Yeah, you should have all hit it at some point. Might have been a while, but we'll see this again in application and some problems. Okay, let's do number 14. Same process. So here again, we're going to have our 2 equations with the same 2 unknowns. I'm going to identify our top equation, the 7h plus 3k minus 12 is my equation number 1. And then the bottom one is going to be equation number 2. So number 1, bless you, 7h plus 3k is equal to 12. And 5h minus 14 is equal to 6k. And that's number 2. Now, in this case, we don't have one of the equations or one of the variables in terms of the other, meaning we don't have one of them isolated. So that's going to be our first step, is to pick one of these equations and one of the variables to solve for. Okay, so which one do we want to do? Sure, we can do the top one. And which variable in the top one do we want to do? Sure. It's right here. It's positive. So anything that we put is going to go to the other side. So I think that's exactly the approach that I took. If you choose to use equation number 2 and solve for k, that's totally fine too. All right. It's arbitrary, but we'll use number 1. So we're going to use equation number 1. And I'm just going to rewrite the whole thing. 7h, plus 3k is equal to 12. And now I'm going to solve for h. So I need to get rid of the 3k. So I'm going to subtract it on both sides. And I'm going to say 7h is equal to 12 minus 3k. And then to clear the 7 away from my h, I need to divide both sides by 7. So it'll cancel on the left-hand side. Now, you could choose to do fractions if you want. I personally prefer to do decimals, but if you do decimals, hold 4 to 5 decimal places. Okay, if you only round to 1 or 2, you're going to have a big rounding error in the end. We're probably going to get some whole numbers here, and we want to be as close to those whole numbers as possible. So I am going to do h is equal to, be a little bit higher so I have space. H is equal to, so I'm going to take 12 and divide that by 7. Okay, and that's going to be 1.7143 minus 3 divided by 7. So it's going to be 0.4286k. So notice I'm holding 4 decimal places. Okay, at least 4. If you want to do 5 or 6, go ahead.
Did you say this was optional to do this?
It is. If you like fractions, some people do. Some people are like, I like doing the fractions better. And then it just comes out. I don't. And most people don't. So you're in the minority. How many people like doing the fractions? Oh my gosh. It's about half. What was that? You're right. But I don't know. Decimals are just easier for me to look at. I don't know. Most people it is. We've got about half. What was that? Exactly. So whichever way. So if you like fractions and you're like, I'm a fraction person, go ahead. Do it with the fractions. Okay. So I've got my h now in terms of k. Okay. I've got my h in terms of k. So now I'm ready to, my next step is going to be, since I used equation number 1 here, I'm gonna, wherever I see H in that second equation, I'm gonna substitute this, okay? So I'm gonna do 5 times 1.7143 minus 0.4286K minus 14 is equal to 6K. Okay. And then now we distribute, okay? Now I can combine what I can. So I got the 8.5715 minus 14. Oh, it needs to be a negative, right? Or does it? Yeah, negative. It's because there's a light over. So do you get K is equal to negative 2/3? Did I do that right? Yeah. It's another reason I have you do it, just to make sure my math is all right. Okay, so once you get K solved for negative 2/3, now because we were in equation number 2, we're gonna go back up to equation number 1 and we're gonna substitute. Now, where you want to go with number 1, remember how we solved for H in terms of K? We're gonna go to that rearranged equation and we're gonna put K into that spot there. Okay, so my third step then, and what I'm going to do is so I can get this on the same page. My third step, I'm going to go up here. This is going to be step number 3 for this problem. Okay, if you number your steps, that's okay. If you don't go successively down, just make sure you number for me. And we're going to take this H is equal to, and we're going to substitute it back up here, 1.7143 minus 0.4286 times 0.6667. Oh, negative 0.6667. Don't forget the negative out front there. And you should get H is equal to 2. Anybody get that same answer? Remember, that's a negative 2/3 here, 0.667 times a negative 0.4286. If you use the decimals I did, and you have to multiply those two together, that becomes positive. So then you end up adding 1.713 plus that product. So 8 should be your 2. So then what you want to do is go back up here and pick one of those and just do a quick check. Again, you don't have to write it out, but it should come out for you. So this is going to be 6 here. And then 7 times 2/3 negative. Did that come out? It doesn't come out, does it? Does it come out? Did I do something wrong?
It comes out to that.
It did. Did I not do that right? So,
Negative 2/3. 3 times negative 2/3.
What they dictate about the value.
oh, that's what I did. The K, yeah. You're right. Yep, it's good. It's good. Yeah. Yeah, so this is gonna be a -2, and that's gonna be 14 minus 2. Yep, I flipped them around. Okay, we're good. All right. Questions about 2 equations, 2 unknowns. So you could, if you like the fractions, go ahead and use those, or if you want to do the decimals, just make sure if you do the decimals, hold at least 4 decimal places so that you don't get those rounding errors early. Okay, let's do 15. Okay. Number 15, you'll notice here I have those asterisks again. So make sure that you write the original equations in the up-down format. Okay, the up-down format. So number 15 is going to be, equation number 1 is going to be b over 2 plus d over 3 is equal to 4. And number 2 is going to be 3b over 4 plus d over 6 is also equal to 4. So here again, we've got fractions. You're going to see that I do it in decimal form, but you can do the fractions if you want. So step number 1 is going to be solving for one of those variables in terms of the other. Okay, in terms of the other. So as I look at these 2 equations, I've got b and d as my 2 unknowns. So you guys tell me, which equation do we want to look at and which variable do I want to solve for? Solve for D? Sure. Okay, so we're going to use equation number 1 and we're going to solve for D. So we're going to do number 1 here. Okay, so I'm going to start by just writing it out in the form that we have here. And I'm going to actually convert to decimals right away. So this is going to be 0.5b plus 0.3333d, right? Because it's 1/3 is equal to 4. So solving for D, I want to get D by itself. I'm going to subtract on both sides the 0.5b. So I'm going to be left with 0.3333d equal to, if 0.5 is positive over here, I need to subtract it on the other side, right? So 4 minus 0.5b. And then we're going to divide both sides by 1/3. Which is multiplying by 3, right? So this is going to cancel on this side. D is going to be equal to, so it's going to be 12 minus 1.5 times B. Okay. So now we've got D in terms of B. So since we used equation number 1 to get this, we're now going to switch over to equation number 2, and we're going to use the second line here. And wherever we see D, we're gonna substitute this value of 12 minus 1.5 times B. Okay, so here again, I'm gonna do my decimals, 0.75 times B plus 1/6 is 0.1667 because it's D over 6, so 1/6 times. Now, instead of writing D, I'm going to do times 12 minus 1.5 B. Okay, is equal to 4. So now I'm going to do my distribution. So 0.75 B plus 0.16667 times 12 is going to be 2 minus 1.5 times 0.1667 is going to be 0.25 B is equal to 4. So I can combine these two right here. So 0.75 minus 0.25. So that's going to be 0.5 B. And then the plus 2 on this side, I'm going to subtract 2 on the other. So I'm going to take this plus 2 and I'm going to minus it on the opposite side. So it's going to be 4 minus 2. So 0.5 B is equal to 2. And then I'm going to divide by 0.5 on both sides, which is a multiplication times 2. And that's going to be equal to 4. So B is equal to 4. Everybody get that? Okay. Now, if you're that far, what you're going to do is you're going to take this 4 and this was number 2 that we solved for B equal to 4. So now we're going to go back to the equation number 1, but remember we rearranged it to solve for D. So we're going to take this B and we're going to plug it right back in right there. Okay. You could go back up to the original equation before we did the rearranging, but here it says D is equal to, and that's what we want to solve for. So our step number 3 now is going to be back to equation number 1, but the rearranged equation to solve for D is equal to 12 minus 1.5 times 4, because that's where our B was. And D then is going to be equal to looks like it's going to be equal to 6. So if we go back up to the top and we put these values in, our B is 4. So 3 times 4 is 12, divided by 4 is 3. 6 divided by 6 is 1. So 3 plus 1 is 4. Okay. Any questions? They're fun, aren't they? Enjoyable. You get to do more just like this on your application problems, right? It's all about mindset. You don't have to, you get to. All right. We've got one more in this set. So number 16, go ahead. And why don't you solve for that? And then I'll do it kind of alongside here. I won't talk through it with you, but let's kind of see if we get the same answer. Does that sound okay? Okay.
What? For this one?
No, they should be the same. It should be lowercase y for all of them. Yeah. Thank you. Thank you for seeing that. Gosh, I think I looked at this about 4 times already and I didn't catch that. So yeah, it's lowercase y everywhere we see y. What was that? Yeah, that's what I thought. What did I do wrong? Do you think? I know. But I feel like, so you had 6.6 y is equal to 7, right? Right, it's gotta be, yeah, oh, I know what I did. I went the opposite way, didn't I? Yeah. 7 divided by 6.6. Yeah, that's what I'm looking for. I'm like, wait a second, this isn't the right number. 1606. There we go. So then this. There we go. Those are the numbers I'm looking for. I'm like, wait a second. Okay. Yeah. And then if you plug those in, this is number 2, back up, then you'll get those to work out. Thank you. What I did was I went 6.6 divided by 7 on accident. Right. So if you want to compare here, the final answer is y is equal to 1.0606. And then x is going to be 0.4242. And if you plug those back up in, I know they're not as easy to do, but in your head, but it does come out to the correct answer. Okay. Make sure that you're in these problems, numbering your steps for me, and then also putting your answers, your final answers with the boxes around them. And again, if you're using the decimal version of a fraction, make sure that you're holding at least 4 decimal places. Okay. All right. That was the last 2 equations, 2 unknowns. All right. So again, we're about halfway done with our homework, right? We got just 2 more sets to go. And we're completing these during class all the time. All right. So what we're going to do is I'm going to take a break there. I'll give you guys another like 10-minute break, and then come back, and then we'll finish up these last 2 sections. Okay.